In this presentation, I will be walking you through how to complete Implementation Requirement Sheet, or IR Sheet, for PA Practice 391, which covers forested riparian buffers. Before we begin 391's IR Sheet, I would like you to keep a few things in mind as you begin. First, it is a good idea to have a general size of your buffer in mind as you're working through the sheet. This can be derived from your site visits or online mapping like GIS, but it will be a good gut check as the sheet produces acreage numbers. The second thing to have a general idea about is the type of buffer layout you'd like to install in the landscape. This will either be a grid layout or a staggered layout. I will define these more in this training. Finally, your buffer's big constraints will be your budget and funding source. The budget will directly affect the number of trees and shrubs you can plant, their size, and the quality of deer protection you can offer a landowner. Similarly, your funding source may have specific requirements for your forested buffer that you will need to meet in order to receive funding. I will discuss NRCS's and ACAP's requirements in this training. So let's dive into the IR sheet. On the left here, you will see a screen grab of the first page of IR Sheet 391. On the right, you will see the Excel version of the sheet in real time. Throughout this training, I will be going section to section, describing what each of those sections are and how best to complete the sheet. You may find it helpful to either have a hard copy of the IR sheet in front of you or a digital copy that you can follow along with. The first section to be completed is probably the easiest. It covers the landowner, also known as the participant's name and information. Our example farm will be the Flick Farm. With that in mind, we will fill out these fields to reflect that information. So with participant here in this gray fillable field, we're going to put Flick Farm. And the locations is the address, which is 250 Bush Hollow Road in Julian, Pennsylvania. And then this is in Center County. So there's a drop down here for the county. We're going to select Center. The other fields on this part of the sheet will be specific to your office, and you should fill it out based on your specific project. The next section of the IR sheet defines a forested riparian buffer. It also provides two example photos. The photo on the left is a newly planted riparian buffer with trees and shrubs and tree tubes. And the right photo shows a well-established riparian buffer. The next section of the IR sheet, the purpose section, allows you to toggle boxes that help to define your project's purpose. They cover an array of purposes that range from pollutant reduction to enhancing habitat to rehabilitating waterways. Feel free to select as many of these boxes that you feel help define your forested buffer project. The next section is the description of how NRCS defines riparian forested buffers. And then the next section will give you your first red field for this IR sheet. For site preparation, you have quite a few options that will take the place of this red field once you select one. Your options will be a drop down from this gray field here. These are the options that populate with that drop down. Their main variance is on the level of herbicide and removal of competing invasive vegetation you will need on your site. Just a reminder here that any herbicide applied to your project should be applied by a licensed herbicide applicator. Also, the last option, no site preparation needed, is extremely rare. I don't think I've ever seen a potential riparian buffer site that doesn't require some level of site preparation. For this training, we will choose option 1. You can see that the red field has been filled with text that gives your contractor clear instructions on how you'd like to prepare your site. Note that this preparation calls out if a planting is to occur in spring, winter preparation is needed. This is usually my preferred sequence of installation. Keep in mind that this will also set up your construction schedule for the rest of the IR sheet. There is also a fillable gray field here at the bottom called site-specific notes. It is a good idea to give the contractor any preparation or operation information that will help inform their installation here. A good example of that information would be if your farm is an organic operation, as that will affect the herbicide application procedures. So moving along in the IR sheet, The next section of the IR sheet asks you to enter the receiving stream or body of water that your forested buffer will be beside. In this fillable field here, in this gray, we're going to enter Bush Hollow Run. The next section of this sheet is where we will begin to enter information that will allow for the IR sheet to populate information for us. I'm going to go through each section and where to obtain that information. For the first thing that I would like to bring up here is this paragraph that you can see kind of boxed here and then here in the IR sheet. Keep in mind that your funding sources will more than likely have sizing requirements for the buffers you are implementing. For NRCS, your buffer needs to be at least 35 feet wide on the narrowest point. On that note, NRCS has other standards that are listed here. Their maximum spacing is 15 feet by 15 feet on center for trees. That would give you about 200 stems per acre if you're following that standard. For shrubs, it's 6 to 8 feet at most on center. You can go more trees per acre than that, and that creates a higher density. That's absolutely fine, but those are the maximums to create a minimum of 200 stems per acre. For NRCS, the first 2 rows from a stream must be deciduous hardwood trees, but after those first 2 rows, evergreen trees and shrubs are acceptable. And on the note for evergreens, coniferous trees are limited to 20% of the overall buffer. For ACAP, when a buffer is called out in an Ag E&S plan, an NMP, or an MMP, or if an ACAP applicant is receiving funding for animal waste storage BMPs or a heavy use protection area, then a 35-foot setback from any stream or water body is required. And what that does is remove livestock's unlimited access to the water. So to help us to start to dimension our buffer, we need some information from the example farm. In this instance, we're dealing with the area between the walkway here and the output from the roofed heavy use area here. The farmer would like to have some visibility to his barn from his pasture. So the barn's located just off of the drawing here, and the pasture's up here. So he's interested in some trees, but would like to remain some line of sight through this area, which means we're going to zone 2 areas in this buffer. To the northwest, we're going to implement a forested buffer, which is the blue polygon here. And then to the southeast, this green polygon will be a grass buffer. Because of the way this IR sheet is set up, it is best to zone out different areas of the buffer at the beginning. You'll see why as we progress, but it will be easier to have one sheet per zone as the sheet works on square footages. If you're planning different types of buffers, use multiple IR sheets. Just make sure to label your site plan appropriately to match your sheets. So next, I'm going to walk you through the left/right our facing upstream means, which is this part of the IR sheet. And you can see that here boxed out as well. So back to our example farm, imagine you're this star standing in the middle of Bush Hollow Run looking upstream. The L or the left will be the dimension to your left, and the R or the right will be dimensions to your right. Also, to make this example a little easier to read, I've made the edge of stream blue and then the constraining fence line yellow for this example. Back to the IR sheet, I would like you to kind of keep these colors in mind as we're working through the sheet. So on the right-hand side, we have red boxes, which correspond to the areas here, or you can see up here trees and shrubs. And then on the right, we have pink boxes, which correspond to grasses or the herbaceous cover. Okay, a few things to keep in mind as you're trying to dimension your buffer. The first is that streams aren't typically straight. To determine your average width off of the edge of stream, you may have to take multiple dimensions, which I will go over. Similarly, things like fences or walkways aren't usually straight either, and it is perfectly fine to square those up as you are dimensioning to make your life easier. Rectangles with straighter lines are easier to work with here. And what I mean by that is that you can kind of see I've straightened off the buffer limits here from the fence line that isn't straight. Now, that being said, as we determine these numbers, we will be determining averages and we will always round up, and this will lead to a higher density of proposed trees, and that is absolutely fine. So as I just mentioned, when you have a curvy stream, you'll want to grab dimensions from multiple points, which you can see here with these red dimension lines. For longer stream segments, you'll have more points. For shorter segments, you'll have less points. In this instance, I used GIS to determine the width and lengths of my dimensions. I know this is hard to read, but we'll zoom in. So first, the easiest to grab is the length of these buffers. So you'll see for trees and shrubs, we have length here that corresponds here. For grasses, we have it here, and that corresponds here. So as we go back to our dimensions, you can see for the forested buffer, we have 150 feet on the left-hand side and 150 feet on the right-hand side. So let's go ahead and populate these here and here. And then for the herbaceous buffer, we have 50 feet on the left-hand side and 50 feet on the right-hand side. So let's go ahead and populate those here and here. Okay. Now for the widths of these, let's zoom in a little bit for each of the sections. For the forested buffer left of stream widths at my dimension lines, I have 50, 35, and 40. And to get that average, we're going to add them up and we'll get 125 linear feet and then divide it by 3 for a total of 41.67 feet. And again, we're going to round it up to 42. So that tells us the left looking upstream average width is 42 feet. So we're going to go back to our IR sheet and fill that in here. Similarly, for the right hand, we have 40, 60, and 40 here, here, and here. You add them up to get 140, divide by 3 to get 46.67, and then we're going to round up for 47 for the right-hand side of this thing. So we're going to input that here. And then for the herbaceous side, very similar situation here. Left-hand side, we have 55 and 50. You add those together, get 105 for the average. We divide by 2 to get 52.5. Rounding up for the left-hand side for the herbaceous buffer, we get 53. And then for the right-hand side, we have 35 and 40, which equals 75 when added. You divide that by 2 for the average to get 37.5, and then round up to 38 for the right-hand side. With those numbers input, the IR sheet calculates 3 things for us. The first is the total buffer size for our forested buffer, which is 0.31 here. It also does the same for our herbaceous cover, which is 0.1 acres here. And then our total buffer acre is down here at 0.41. Moving forward, this 0.31 acreage is what we'll use on this sheet for IR sheet 391. And then the 0.1 acreage is what we will use on IR sheet 390 for herbaceous buffers in another training. The rest of this page of IR sheet 391 allows you to take that 0.31 acres that you just determined and input it into fillable fields. The sheet will then calculate quantities of plant material you would need to implement your buffer. You have 3 different buffer options. The first is direct seed, the second is live stakes, and then the third one is trees and shrubs. I will be covering trees and shrub buffers in this training. Please note that as we're scrolling in the IR sheet, that once we input these numbers up here, it actually pre-populates down here for us. So our 0.31 that's up here appears down here. And then the sheet actually calculates how many trees and shrubs we would need for that acreage. So respectfully, we have 43 trees and 19 shrubs. The other thing that I want to signpost here is that for IR sheet 391, it is set up to give us numbers that create a staggered buffer layout. And in this case, that would be 15 feet by 13 feet on center. We'll discuss that layout a little bit later, but you can see it called out here. And as you're reading, you'll see that here as well. Please also note that this IR sheet calculates the maximum number of conifer trees that would be allowed for this project. Remember I said that 20% of your buffer can be evergreen. So in this instance, only 12 of our trees, whether that be a pine, a spruce, or a hemlock, or etc., could be coniferous. They limit this because evergreen trees tend to be shorter-lived species, and they can become an issue in early spring or late winter flooding. Instances of floods like that can uproot those trees because they have more mass at that time of year than deciduous trees would, because those trees would be leafless. The next section of this IR sheet allows you to start selecting the types of trees and shrubs you'd like to see in your buffer. Each column is either a drop-down or a fillable field. The site column allows you to select your site conditions as either dry or wet. Once you select that, the tree species drop-down is activated and you will be able to populate with a pre-described list of plant species that would be appropriate to those site conditions. Those plants, that list, are to NRCS standards and are what we are limited to use if we are reaching for NRCS standards. But just signposting that NRCS will allow substitutions if you get permission. This middle column is a fillable area where you can put in your specifications for the size of your plants to your contractor. This could vary from bare root stock to containerized stock, or even stock that is ball and burlap. And then finally, the plan number column is where the total number of plants you're proposing for each species. You will take the total number of trees, which we have up here, and then divide it out dependent upon how many tree species you'd like to have in your buffer. So if the last two sheets are side by side, so you can kind of see up here what I'm talking about, and then kind of looking down here, our tree pieces will go to the top, which corresponds here, and then our shrubs will go down here. The total number of trees will also include any conifers you'd like to include, and we'll talk about that in a minute here. So let's go ahead and fill this sheet out. Let's select 2 wet trees and 2 dry tree species. So let's select those here. So the first one we're going to do is a wet. And as you can see, the sheet is thinking. We're going to go ahead and choose a sycamore here. Our second wet tree is going to be a swamp white oak. For our first dry tree, we're actually going to select a pine. And in this instance, we're going to do a white pine, just so I can show you guys how to schedule a conifer here. And then our last dried tree species is going to be a hickory. And for this example, we'll use the shagbark hickory. So as you can see, once we've made those selections and the drop downs, we want to find a point over here that's not going to overlap with that, so we're not writing over the information that we're trying to convey. And what we're going to type for this example is containerized, and then SP5. That's the size of the container plant that we're going to schedule for these plants. So once we have that typed, we can put that in the other lines here as well. So similarly down here with our shrub species, we're going to have 1 dry species and 1 wet. For the dry, we're going to do a dogwood. In this instance, we'll do a flowering dogwood. And for the wet, we're going to do an elderberry. And again, in this middle column, we're going to schedule that out as containerized SP5. Again, that could be a 3-gallon, that could be a 5-gallon. SP5 is typically the smaller seedlings that you're going to see. So once we have those columns figured out, we're going to fill out our plan numbers. So for the sycamores, let's go ahead and put 11. For the swamp white oaks, let's put 10. For the white pines, let's put 12. And for the hickories, let's do 10 again. For our shrub species, we're going to do 10 elderberry and 9 dogwoods. And what I want to signpost here, you can see that some of these fields are red, but as we were filling out these total numbers and getting them to equal what was prescribed up here is 43, that was no longer red. So say I drop my oaks down to 9, which would be below that 43 down to 42, that's telling us something is wrong. So we need to keep it at least to what is being prescribed up here for our totals here. Same thing with the shrubs, we're equaling 19. Now the other thing I want to signpost here too, we have a maximum total of 12 conifers allowed for this project, and we maximize that out for our pines down here at 12. So as we continue on here, we're going to go over how to fill out your selections for tree and shrub protection. So for tree shelters here, this shelter type field is a drop down. It gives you 3 options: solid mesh combo, or fence. I'm sorry, that's 4 options. You also have a drop down for shelter height, and those are 4 foot, 5 foot, or 6 foot shelters. And then there's a fillable field here for the number of tree shelters for conifers. So you're going to want that to match automatically how many conifers you're scheduling up here. So we know that that's 12. We have 12 white pines up here, so that needs to match down here. And then our total plan number is going to equal the difference there. So 43 minus 12 is 31. For this example, for this shelter type, we're going to go ahead and go with mesh. So we're going to select that in our drop down. And we're going to do the pretty typical shelter height of 4 foot here. So you can see that the IR sheet is thinking it's starting to pre-populate some things for us, but we also need to do the same thing for our deciduous shrubs. So again, we're going to select mesh. It's good to have that kind of line up across a project. And again, we're going to go with 4 foot here. So as you can see, the sheet is thinking, but once we then put in 19 here, which is the number of shrubs we have, this will now spit out the number of tree shelters, the number of bird nets, the number of cages, the number of tubes, and then the stakes for all of that. So that does all of the math for you. At the bottom of this page, we also have a gray fillable field. What I like to do here, it's an opportunity to really type in any required weed control options you might want for your buffer. So that could be your geofabric, gravel mulch, or wood mulch, but this is your opportunity to tell your contractor what you'd like to see there. So these are really your options. You can go ahead and type what you'd like that to be here in that section. So this section of the IR sheet starts to get into buffer layout. On the left are diagrams for grid and staggered buffer layout options. You can see that here and here. And then on the right is the geometry of how to get a layout to a staggered buffer, which I will discuss a little later. So grid buffer layouts are structured and evenly spaced between rows and columns. They form a tight canopy that reduces weed competition. And this layout also makes it really easy to mow between the plants. For staggered buffers, they are laid out in a zigzag pattern. This also forms a tight canopy like the grid pattern, which reduces weed competition. However, the staggered layout is preferred by NRCS, which is why this IR sheet is set up for it, because staggered layouts prevent water from channeling straight between columns, which adds to stream bank stabilization. Okay. For the next section, we're going to be working through dimensioning the staggered layout. First, because we entered our average buffer width above in this, so as you kind of go back up here, once we put these numbers in, so the 42 and the 47 respectfully here, it actually pre-populates down here. So with that in mind, that sets up your geometry for A. So as you look at this, A is the total average width of your buffer. So from your stream to your buffer boundary there. For B, it's going to be the distance between your stream and your first row of trees here. So for this example, we're going to go ahead and input 3 for B. And there, again, there's a fillable field for it. C is going to be the distance between your tree rows. You can see that it's red and that we have a corresponding red text here that says that it must be greater than or equal to 15 feet. So knowing that our NRCS standard is that it can't be more than 15 feet, we're going to go ahead and put 15 feet in for C, which is, again, the distance between our tree rows. Now for D, that's this other distance between rows. You're going to see, as we're thinking through this, we're trying to set up that 15 by 13 foot spacing to keep the stagger. This is going to make the sheet mad. And what I mean by that is, unfortunately, IR sheet 391 is broken. We confirmed this with NRCS and they're actively working to fix it. But the issue is this: after inputting 13 feet here, which you can see is this dimension for D, we get an error telling us that the number must be lesser than or equal to 12. We're going to keep the 13 foot here as directions to the contractor, just simply because we know that that is what it needs to be based on this sheet being a spacing of 15 feet by 13 feet. Another issue with IR 391 comes with dimension E, which is the distance between shrub rows. You can see here that the direction is that it must be greater than or equal to 15 feet. But if you'll remember, our maximum distance between shrubs should be 8 feet. So to keep this correct with what we're talking about with NRCS standards, we're actually going to force 8 here. And then for F, which is the distance between the rows for shrubs, we're going to put 6. And so what that does is keep the stagger for us. Our last distance here to consider is G, which is the distance between our last shrub row and then the boundary. One thing that you should really be thinking about here is that a lot of times that boundary for the buffer is typically adjoining a pasture, and we need to keep in mind the reach of animals so they don't reach over and eat our plants. So with that in mind, I'm going to put in 10 feet for this. So at the end of the day, as we define these points A through G and how they correspond to this, a contractor would be able to lay out our buffer based on those spacing and based on the widths that we're allowing based on what we measured for the buffer. So the next section of this IR sheet is about establishment of new riparian forest buffers. Nice little overview there. And then the last section is an overview of operation and maintenance, which is very brief. And because these last two sections are so brief, my recommendation is to supplement both of those instances, both establishment and overall maintenance, with additional resources from Penn State Extension's extensive library. And that'll give you an opportunity to really tailor additional information for your landowner's needs. And this concludes the training for 391. Kaylee, can you come back?
Sorry, I'm back, and then I accidentally muted myself again.
I think that went pretty well for a first run through, don't you?
I truthfully wasn't fully listening. I mean, you only stopped once, so I'm gonna say that sounds good.
Yeah, that I forget what tripped me up, but that'll be easy to cut out here, I think.
Yeah, no, not a big deal. So I guess here I can stop recording.